Okay, good morning, good afternoon, good evening, everybody. What we're going to talk about today is the volume of a composite figure. So, what that means to us, a composite figure is when we have compounding shapes of two or more simple shapes, such as triangles, squares, circles, and rectangles. So another name for a compound shape is a composite shape. And an example of this would be a triangle placed on top of a square. So for example, if I have a square, that's one shape, and then a triangle on top of it, that's two shapes. So that would be giving us our composite figure, right? We have two shapes, compound shape or composite figure. Those two things mean the same thing. And what we're going to talk about today is going to be volume. So what we're going to look at is three-dimensional shapes. Now, with two-dimensional shapes, it's usually pretty straightforward to find the area because we can clearly see our two shapes. With volume, the issue I find for most students is really identifying where those two shapes are. So for example, here we have this shape that kind of looks like a bench, if you will. And so what we have to decide is how do we want to break this into two rectangular prisms? So what I mean by that is that we could look at the back of this piece as one. So you can kind of see I'm taking this bottom part here and I'm looking at one big piece in the back. And so then my second piece to this shape would be just this bottom part down here. So I'm looking at then this second piece, right? So I have my blue piece and I have the red piece. So the blue piece would be that back part and the red piece would be that bottom part if we were to think of this again as a bench. Now where this can get tricky is that I could have also looked at this as the bottom part extending to the back and looking at this as one of my pieces of my shape. And then I would have taken just the top part of that back. So again, really looking at how we want to break up those shapes. So here now that red piece is going to extend into the bottom of the back of this bench, if you will. So we really have to be mindful of how we're looking at that. Some of the shapes will be cut for us so that we can see where those two pieces are coming from. But when it's something like this, where it's all given one piece together, we have to decide visually how we want to cut up that shape. So our first example here, this shape is really nice that it is clearly cutting two different pieces for us. So we see that green piece and the blue piece. So to find the volume of our compound shape, I would like to find the volume of the green piece and then the volume of the blue piece, and I'm going to add those two together. That's where we're getting the total volume. So in finding the volume of the green piece, so here my volume, if you guys remember, is length times width times height. So I need three dimensions here. So I see that along the side, I have, we'll call that the height of 6 centimeters. I am also going to have, we'll call this a width up here of, so this is going to be my height, and this will be my width, and this will, on the back part here, be our length. Okay. So to find my volume, I'm going to do length times width times height, okay? So to calculate our volume out, 3 times 3 is going to give us 9, and then we're going to do 9 times 6 to get our total volume for the green piece as 54, and this is centimeters, and we're talking about volume, so I'm going to say centimeters cubed. Okay, let's see if I can close that out. Okay. Now I'm going to look at my blue piece, and this is where things can get a little bit trickier because I don't really have any of the dimensions of the blue piece labeled. I'm going to have to figure them out myself. So for example, this total bottom length here, so I'm talking about this 5 centimeters, is giving me the total length from all the way from the left to the right. So what I have to notice here is that the 3 centimeters on the top is also going to be the same 3 centimeter section here. So if my total length is 5 centimeters and I know that that green portion is 3, the remaining blue portion here is going to be 2 centimeters. Now I know that the total length here height of the green shape was 6 centimeters. but that part of it cuts down to 4 centimeters. So that remaining height happening here, 6 centimeters minus 4 centimeters, again, giving us 2 centimeters. Okay, so again, because this is where it can get a little tricky, that we have to really look at the pieces that we're given in order to fill in those missing pieces. Now I have, so we'll call this our length, we'll call this our height, and so what I'm missing here is my width of this shape, so either one of these two pieces. Now again, where I have to look at this is the extending from, let's say, the front to the back, which is the same thing we had in our 3 centimeters here. So this 3 centimeters will be our width. So now for the blue piece, I want to find my length times width times height. And so again, I'm going to do 2 times 3 times 2. So I multiply 2 times 3 first to get 6. And then I multiply that 6 by 2 to get 12 centimeters cubed. So I found the volume of the green piece, I found the volume of the blue piece, but now I want to answer it by finding our composite volume. So the total volume is going to be the 54 centimeters cubed plus the 12 centimeters cubed. And so my total here is going to be 66 centimeters cubed to get our total composite volume, right? Because we're adding the 54 and we're adding the 12. So to summarize this, we can see down at the bottom here, we've got a nice little summary that to find the volume of a composite figure, we're going to find the individual volumes and then add them together. So that's exactly what we just did in the red, was that we took those two pieces, the green box and the blue box, and we added those together to get the total composite volume. All right, so let's try this again. All right, so we want to try this with these two shapes. We want to find the volume of the shapes below. So number one is really nice that, again, they've divided this up for us so we can clearly see two different pieces here. So I'll draw in the back piece here. And then we're going to have this side piece. We'll make this in blue. So I can clearly see these two different shapes. What's also really, 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 really nice about this first question is that all of our dimensions are labeled for us. So this one should be pretty straightforward. So I have the blue pen enabled, so I'm going to just start with that piece. So again, we're going to do length times width times height. Okay, so the 6 centimeters is going to be my length, and then my 6 centimeters on the side will be my width, and then the 4 centimeters will be our height. So finding this volume, I'm going to do length times width times height. Okay, so finding our volume, I'm going to do 6 times 6 to get 36, and then I'm going to multiply that with 4, and so we get a volume for this blue shape of 144. We have centimeters again, centimeters cubed. All right, now I'm going to switch on to the red box here. So I have a length in this case of 2 centimeters, a height of 7, and our width here is 6. Now, when I'm labeling these lengths, widths, and heights, it really does not matter. We're multiplying those three things together. Multiplication is commutative, so I could have easily said, 2 times 6 times 7, or 2 times 7 times 6, or 6 times 7 times 2. So it definitely really doesn't matter so much as to which one I'm calling my length, my height, and my width. I'm just labeling those with the letters so you understand when I'm substituting them in here. That when I'm talking about the length, I'm going to pull that 2, and that when I'm talking about W for width, I'm going to pull that 6, and when I talk about H for height, I'm going to pull that 7. Again, we're going to do 2 times 6, that's going to give us 12, and then we're going to multiply that 12 times 7 to get a volume of 84, again, centimeters cubed, because we're talking about volume, we have 3 dimensions. So now I found the volume of the blue piece, I found the volume of the red piece. To find my total composite volume, so total volume, I'm going to do 144 centimeters cubed plus 84 centimeters cubed, and I'm going to add those two together to get a total of 228 centimeters cubed to get our total composite volume. Okay. All right, so now for our last example here. This one goes back to, again, it's a little tricky that we don't necessarily have those two shapes cut very obviously. So it's totally up to us to decide how we want to cut those shapes. And it is really, truly a choice of how you're going to cut it. So what I mean by that is that I could make this back piece all one piece here. And then I would make the front part of this all one piece. So I can cut it like this and say, what's the volume of the back, again, of this bench, and then what's the volume of just that front piece, like where we would sit if we were to think of this again, like a bench. So I can cut it up like that, or I could cut that the bottom piece goes totally across here. And then I'm looking at, then my top piece here would just be this. Okay, now since I just finished labeling it like that rather than have to draw those again, I'm going to leave it like this, and this is how we'll calculate our volume. So I'm going to calculate the volume of the blue piece, again, with length times width times height. So I need to get my dimensions here. Now, I have this 7 centimeters being this total distance on the side here. So what I have to be very careful of is I really need to know this piece of it, not the total length. So I have to look at anything else that would be kind of this height here. And what I'm going to see is that I have this 4 centimeters on kind of that front right of this bench, if we will. So I am going to do 7 centimeters minus that 4 centimeters. And so I'm going to be able to break this up into 3 centimeters and 4 centimeters. So this piece right here will be 3 centimeters. So I have my height. I have, we'll call this a width, and then I really need to find this length back here of how far deep we go. Now this is where I can look at my other labels in this dimension that I'm going to see from this front that I have 10 centimeters here, and that's going to correspond with this side of 10 centimeters as well. So I know that this can be really tricky visually to see where those numbers are coming from, so please be mindful of the fact that this is something that if you have a hard time visualizing those 3D shapes on a 2D picture, right, because we're really talking about volume, something with 3 dimensions, and we're representing it on a piece of paper or on our computers, which is 2 dimensions, just length and width. So it can be a little tricky to see at first. So what we're going to multiply here is 3 times 3 times 10 to get our blue volume, 3 times 3 giving us 9, and then 9 times 10 giving us 90, and we have another centimeters cubed. These ones are really nice on the units, that these are all giving us centimeters cubed, so that's really cool. Okay, now we're ready to do the red box. So we're going to do volume equals length times width times height of the red shape. So this one, I'm actually really happy with how this is set up because I have my 8 centimeters labeled for me. I have 10 centimeters labeled, and I have 4 centimeters labeled. So again, I have, let's say that length, width, and height already given to us. So this one, I don't have to worry about puzzling in any missing parts here. I can do 8 times 10 times 4. All right, so here we have 8 times 10 giving us 80. Multiplying that by 4 is going to give us a total volume of 320 centimeters cubed. Now we're not done yet though, because we need to find our total volume. So this is a composite figure, so it's not just looking at the volume of the top or the side. So our total volume, we're going to do 90 centimeters cubed plus 320 centimeters cubed to get a total composite volume of 410 centimeters cubed. All right, so the big thing with these composite figures is that we need to identify what pieces we're looking at and that we're going to break that shape up. So sometimes it's done for us like we saw in the first 2 examples. Sometimes it is not done for us like we just saw in this example number 2. So we really want to be mindful as to where we're labeling those pieces. It can be a little confusing visually, so take your time, label your sides. It does really help to have 2 different colors like I've been doing here. So I do really recommend that if you're writing on a piece of paper or even if you're writing on your Chromebook to pay attention to those dimensions. All right, thank you guys very much, and look forward to your assessment on this.